We want to find a formula for the sum of an arithmetic sequence. First, let's let S represent the sum. And let's write the sum two different ways. So S, my sum, would begin with the first term of the sequence, a sub 1. Then I will add the second term of the sequence, and I'll add the third term of the sequence, and I would keep doing this until we added all the terms of the sequence, which would get me to the last term of the sequence. And the last term of the sequence is denoted by a sub n. But we need to determine how to write the second term of the sequence. This requires us to go back to our definition of an arithmetic sequence. We know that a sequence will be arithmetic if the consecutive terms have a common difference. So if I have the first term, a sub 1, then I would add the common difference, d, and that would give me the second term. So the second term of my sequence will be a sub 1 plus d. Now we need the third term of my sequence. Well, if I continue adding on another common difference, then I have a sub 1 plus d, which is really 2d. So the third term of my sequence is a sub 1 plus 2d. And this would continue on and on until we added all of the terms of the sequence. So this is one way to define S. Now let's define S a second way. What if we began with the last term of the sequence this time? The last term of the sequence is a sub n. And now we want to add the second to last term of the sequence. And then we would add the third to last term of the sequence. And we would keep adding, working backwards, working our way through the sequence until eventually we worked our way back to the beginning, to the first term. So the last value we would add would be the first term of the sequence, which is a sub 1. Now we need a way to write the second to last term of the sequence. If we begin with the last term, a sub n, and we're working backwards this time, then we're not going to add the common difference, but rather we will subtract d, the common difference. So my second to last term is a sub n minus d. And if we continue doing that, to get the third to last term, we would subtract another d. A sub n minus d is really a sub n minus 2d. And we'll continue doing that on and on until eventually we've worked our way back to the beginning of the sequence at a sub 1. So right now we have two different ways of defining the sum of the sequence. Let's treat this like a system of equations. And now let's go ahead and add these two equations together. It's as if we're using the addition method or the elimination method for solving a system of equations. So we're going to add straight down. On the left side, we have s plus s is equal to 2s. Now on the right side, when we're adding straight down, we have a sub 1 plus a sub n. I'm going to write that as the quantity a sub 1 plus a sub n. Moving on, let's add the next two values. A sub 1 plus d plus a sub n minus d. And you'll notice that the d's are going to subtract out. So we have another quantity a sub 1 plus a sub n. When we add the next two groups, a sub 1 plus 2d plus a sub n minus 2d, we see the 2d's subtract out. Now we have another quantity, a sub 1 plus a sub n. And this subtraction is going to happen every single time for every set of terms. Then we get all the way to the very end where we have our last set, which is a sub 1 plus a sub n. So it's useful to note right now that all of the common differences, d, have subtracted out. Now we have all of these quantities a sub 1 plus a sub n, and the question is, how many? How many of these little quantities do we actually have? Well, if we were only adding the terms in a sequence that contained 3 terms, then we would have 3 of these quantities. If our sequence had 4 terms, then we would have 4 of these quantities. So because we're generalizing, our sequence has n terms, so we have n of these quantities. Therefore, rather than writing it repeatedly as addition, we can simplify the right-hand side as n times a sub 1 plus a sub n. This gives us 2s is equal to n times a sub 1 plus a sub n. Our goal in the beginning was to find a formula for s, the sum of an arithmetic sequence. So we can finish solving this equation for s by dividing by 2. And this gives s is equal to n times a sub 1 plus a sub n divided by 2. Now this is the form that I prefer to write this formula in, but let me mention there are other ways of writing this. You might find it in a textbook written as 1/2 times n times the quantity a sub 1 plus a sub n. And that's equivalent. It's the same formula, just written in a different form. The reason why I do like this form here is because a useful way of thinking about this formula is noticing that a sub 1 plus a sub n divided by 2 is actually the average of the first and last terms. And sometimes that's a useful memory trick to help you remember the formula. So it's the average of the first and last terms, since you're adding the 2 and then dividing by 2. Then we're multiplying by n, and n represents the number of terms. So essentially this formula is the same as multiplying the number of terms by the average of the first and last terms. And this is our general formula, which will give us the sum of an arithmetic sequence.